if we go back a couple of years, in the industrial world, when you wanted to get data, if you were already a bit more advanced, you had something like an historian. There are several historians out there, but they have one thing in common, that's that they are really, really good in storing time series data. Some are also good in getting data back out of the historian, others a little bit less, but that's what you would have on the OT side, and then you would have some kind of trending capabilities, either built in or using an external tool to access that data, your operators, your process engineers, etc. On the IT side, you had your data lakes, your data warehouses, your BI tools, your more advanced data science environments, etc. But the two, if you wanted to, I would say, bridge the IT-OT data gap, then you would end up with custom work somehow, custom interfaces. On the IT side, not really capable of handling time series data, or at least not the time series data as we like to use it. And then I mean particularly contextualized time series data. So that means with an asset model, UNS alike visualization, but also using, for example, embedding operational context, like what batch was active, was I'm undergoing maintenance, quality information, etc. So linking that operational context to time series data is something which and I would say at least until a couple of years ago was rather difficult, maybe even impossible on the IT side. So you had this clear two distinct silos, and then even on the OT side, what you see is, or what you still see basically, are several separate systems which have their own function, and so your maintenance system and your quality system and your historian, and maybe you're using IoT data, so you probably have another system which holds your IoT data, maybe somewhere in the cloud. So you have this large set of different sources which are typically not linked together, which means that if I'm a data scientist, or a process engineer, or whoever needs to get access to that data, then you basically you find yourself pulling it all together into an Excel sheet in most cases, and then you're trying to actually make those contextualized links yourself. It's manual work. I've done it myself as well in the first years of my career. It's something, if you have a data or a process or whatever background, that's not the thing you want to do, because it's really a waste of time. And even worse, you do that one time for one analysis, and then the next time you want to do another analysis, you basically need to repeat the same work, because you can't really, there is no economy of scale in that approach. So that's where a platform approach comes in. And so before we go to the capability map, I need to explain you what the platform is. So the platform means that, as we also have on the IT side, think about it as like a combination of a data lake and a data warehouse, more or less. So we start with making sure that all our different data sources, they come together in one centralized platform, being it on-prem or in the cloud or in a hybrid variant. That's all possible, and that will highly depend on your industry and your use case. But still, data needs to be there as one single source of truth. That's more your data lake type of thing. And if we want to make it more into like what a data warehouse would be, then we should also bring in that contextualized data, so your asset context, etc., etc. For example, having this single pane or this single view where you have your structure, but one data point comes from the historian, another data point comes from the MES system, etc. So that's really important. And then you have all your applications and users who are then consuming that data from that platform, meaning that no custom interfaces anymore, no PowerShell scripts, no CSVs on an FTP server or whatever. All that complexity is gone. And really, really important, the data in that platform obviously it's a living asset, which means that every time you build a new use case, you're probably gonna improve your asset model. You're gonna improve your context. You may be gonna clean data, for example. So you might also bring in clean data in the platform, or maybe you made a very clever machine learning model. And if you then also can bring in the results of that machine learning model again into the platform, then the platform becomes smarter and smarter and smarter, which means that the people who are using the data in the months and the years to come, they will always have access to better and better data and smarter data. And they will need to do, I would say, their work in integrating, cleaning, contextualizing, validating data actually becomes less. So that's the dream, right? If we can build this thing in the middle, then we can really start scaling our data initiatives. But between dream and reality, there is work to be done. And that's exactly what the capability map is.